Variable and average cost. In the previous section, we learned how to calculate marginal cost, that is, how much it costs to produce each additional unit. Now, we will expand and learn to calculate two more concepts, total variable cost and average variable cost per unit. These two concepts are very important for understanding the producer's behavior in the short run. Let's return to our example. We have a printing machine and workers. The machine is a fixed input, it's already there, already purchased, and we cannot change it in the short run. What we can change is the number of workers. The workers are the variable input, and therefore their cost, the wages, is the variable cost. Let's build the full table, step by step, with 8 workers. The wage per worker is 4,000 shekels. In perfect competition, all workers receive the same wage. You can't pay one worker differently because if one employer offers less, the worker will simply go to the employer who pays more. So, it doesn't matter if it's the first worker or the 8th worker, they all get 4,000 shekels. We'll start with the production function, the total output for each number of workers. Worker 1, total output, 100. Worker 2, total output, 220. Worker 3, total output, 360. Worker 4, total output, 480. Worker 5, total output, 570. Worker 6, total output, 640. Worker 7, total output, 690. Worker 8, total output, 720. Now, let's calculate the marginal product, how much each additional worker contributes to production. This is simply the difference between two consecutive total output levels. Worker 1, marginal product, 100. Worker 2, marginal product, 120, 220 minus 100. Worker 3, marginal product, 140, 360 minus 220. Worker 4, marginal product, 120, 480 minus 360. Worker 5, marginal product, 90, 570 minus 480. Worker 6, marginal product, 70, 640 minus 570. Worker 7, marginal product, 50, 690 minus 640. Worker 8, marginal product, 30, 720 minus 690. What do we see? At first, when we add workers, the marginal product rises, from 100 to 120 to 140. But starting from the 4th worker, the law of diminishing marginal returns kicks in, each additional worker contributes less than the previous one. Worker 4 contributes 120, worker 5 contributes 90, worker 6 contributes 70, and so on. The machine starts getting crowded, workers interfere with each other, and the additional output from each worker declines. Now, let's calculate the total variable cost. What is total variable cost? It's very simple, the number of workers multiplied by the wage per worker. Worker 1, total variable cost, 4,000. Worker 2, total variable cost, 8,000. Worker 3, total variable cost, 12,000. Worker 4, total variable cost, 16,000. Worker 5, total variable cost, 20,000. Worker 6, total variable cost, 24,000. Worker 7, total variable cost, 28,000. Worker 8, total variable cost, 32,000. Total variable cost rises steadily, each additional worker adds exactly 4,000 shekels to the total cost. This makes sense because the wage is fixed for every worker. Now we move to marginal cost per unit, denoted MC, marginal cost. Marginal cost per unit is calculated as the wage per worker divided by that worker's marginal product. Worker 1, MC equals 4,000/100 is equal to 40. Worker 2, MC equals 4,000/120 is equal to 33.3. Worker 3, MC equals 4000/140 is equal to 28.6. Worker 4, MC equals 4000/120 is equal to 33.3. Worker 5, MC equals 4000/90 is equal to 44.4. Worker 6, MC equals 4000/70 is equal to 57.1. Worker 7, MC equals 4000/50 is equal to 80. Worker 8, MC equals 4000/30 is equal to 133.3. Notice the pattern. At first, marginal cost decreases, from 40 to 33.3 to 28.6. Why? Because marginal product is rising, so each additional unit costs less to produce. But from the fourth worker onward, when marginal product starts to fall, marginal cost begins to rise, 33.3, 44.4, 57.1, 80, and 133.3. Marginal cost is a mirror image of marginal product. When marginal product rises, marginal cost falls. When marginal product falls, marginal cost rises. Now for the concept that really matters to us, average variable cost per unit, denoted AVC, average variable cost. The calculation is total variable cost divided by total output. Worker 1, AVC equals 4000/100 is equal to 40. Worker 2, AVC equals 8000/220 is equal to 36.4. Worker 3, AVC equals 12,000/360 is equal to 33.3. Worker 4, AVC equals 16,000/480 is equal to 33.3. Worker 5, AVC equals 20,000/570 is equal to 35.1. Worker 6, AVC equals 24,000/640 is equal to 37.5. Worker 7, AVC equals 28,000/690 is equal to 40.6. Worker 8, AVC equals 32,000/720 is equal to 44.4. Now pay attention to something very important. The average cost per unit doesn't just rise, it forms a U-shape. At first, it falls, 40, 36.4, 33.3. Then it reaches a minimum point, around workers 3 to 4, where AVC is 33.3. From there, it starts to rise, 35.1, 37.5, 40.6, 44.4. This is the classic U-shape. Why does this happen? Because of the relationship between marginal cost and average cost. It's exactly like averaging grades. If you get a new grade below your average, the average goes down. If you get a new grade above the average goes up. The exact same thing happens with costs. At first, marginal cost is below average cost. For example, at worker 2, marginal cost is 33.3 but the average is 36.4, marginal cost is lower than average, so it pulls the average down. At worker 3, marginal cost is 28.6, still below average, so the average continues to fall to 33.3. But from worker 5 onward, marginal cost is already above average cost. At worker 5, marginal cost is 44.4 but the average is only 35.1, marginal cost is higher than average, so it pulls the average up. As marginal cost continues to rise, it pushes the average up at an increasing rate. The minimum point of AVC is exactly where marginal cost crosses average cost. At this point, MC equals AVC. Before this point, MC is less than AVC, so the average falls. After this point, MC is greater than AVC, so the average rises. It's also important to note that average cost changes more moderately than marginal cost. For example, from worker 5 to worker 8, marginal cost jumps from 44.4 to 133.3, almost tripling. But average cost only rises from 35.1 to 44.4, a much more moderate increase. This happens because the average includes all previous units that cost less, so it smooths out the impact of the high marginal cost. One last important point, marginal cost, MC, reflects the producer's supply curve in perfect competition, but not along its entire length, only from the point where marginal cost starts to rise, that is, from the point where the law of diminishing marginal returns begins to operate. We will expand on this later. To summarize, we learned to calculate three things. First, total variable cost, the number of workers multiplied by the wage. Second, marginal cost per unit, wage divided by marginal product. Third, average variable cost per unit, total variable cost divided by total output. The key point is that AVC forms a U-shape, it falls when MC is below it, and rises when MC is above it. These tools form the basis for finding the profit maximizing point, which we will study in the next section.